Hello, and in this video we're going to deploy a Python Lambda function alongside a AWS API Gateway. We're going to tie them together using the Serverless framework. It's written on top of nodejs, and I'm going to go ahead and install Homebrew in order to install nodejs. I'll go ahead and post the Homebrew link for you so you can just easily copy and paste it. Brew install node. Looks like I already have Node installed. Let's head over to the Serverless Framework website and see what it takes to install it. Their website will give us all the commands that we need to focus on. The first one is to globally install the framework. Now that we have it installed, let's find out what kind of templates they provide for us. I forgot to supply the template name. Okay, template. Alright, here you can see that true is not supported. However, we have a huge array of supported templates. Node.js, TypeScript, just Python, Python 3, Gradle, Java, the list goes on. All these are the languages we could use. I want to create a Python 3 template. So let's go ahead and do AWS-Python 3, not 2. Alright, let's find out what it created. Oh, let's go ahead and put this inside of a directory of its own. I'm working on a project called AWS Overflow, so I'm going to make that directory, cd into it, and rerun my template command. Yeah, I think this is what I was after. Alright, let's head over to the editor and figure out what handler.py is and serverless.yaml is. I'll be using PyCharm, and if you're not accustomed to PyCharm, don't worry. It's straightforward and you'll know exactly what I'm writing. Now we have the YAML and the Python file. What am I trying to do? I'm putting them next to each other. There we go. Okay. Let me close this window, and we don't need any of these comments. You can look at them when you're ready, but I'm going to remove it and you'll see how small this file really becomes. If you're following along and you have the project open in front of you, the first line called service, I'm going to rename it to AWS Overflow. It's going to be the name of your project. I do apologize, I noticed that it's cut off. The name is AWS, we're deploying to AWS. The runtime is Python 3.6. Now I'm going to add a couple more parameters here. One of them is going to be version function. Functions, plural. And I'm going to make it false. This tells AWS Lambda not to store multiple versions of your function. That's basically what Git is for, and you'll eventually run out of space on Lambda. You do have a code size limit. The next one is going to be memory size. This one is going to set a default memory of 128 megabytes for every single function we make. However, we are allowed to override them in each function. Most functions won't need to be higher than this if they're quick data lookups. The other one is which region we want to deploy to, which is going to be US West 2. I like it, it's cheaper, and it has a lot more bells and whistles. It's more experimental though. Don't worry, everything here has nothing to do with experiments. And under functions, we have the function name, which is hello, that's arbitrary. And we have the Python file, which is handler, and the function, which is hello, so handler.hello. Now within the same file, we could tell AWS to create a URL for us. So we're going to create events and HTTP. The path is going to be, what should I call it? Echo hello. All right, we'll just have it say echo hello. And the method is going to be a get method, so we don't have to post anything to the URL. That's everything we need on the YAML side. That'll get us our gateway and our Lambda. let's clean up the Python file. This file is going to be pretty small. I think you'll be surprised. We'll need to worry about a very specific payload that Lambda does require, and it is supplying the status code and body. So I'll go ahead and make a dict status code, which is going to be status code 200. This is very important. If you don't have this, you will get errors. Lambda does allow you to return many data types. One of them is JSON serializable objects. Another one will be binary, and even CSS or HTML. In the upcoming videos, I'll show you how to run a fully functional dynamic site using only Lambda and API Gateway. Before serverless will actually work, we need to give it AWS keys. So head over to your AWS console, go to IAM, and this will allow you to create new users, groups, or policies. Let's add a user, and my user is going to be AWS Overflow, since it's the project that I'm working on. You only have to click Programmatic Access. You're going to see my keys, but don't worry. I'm going to delete them right after this video. The next screen is going to allow us to add permissions. I'm going to give administrator permission to my user. I highly recommend against this. I'm doing this just to show you how easy it is to get up and running with no permission issues. And if any of you are familiar with coding or systems or IT, permission issues are very common. Before we could deploy to AWS, we have to tell serverless about our credentials. Okay. SLS is the alias for serverless. So SLS config credentials, if I can spell. The provider is going to be AWS, and we need to give it the key, which is our access key, and then our secret key, which is in the line, just secret. Finally, copy the secret key over and hit enter. And then we could type SLS deploy and our stage, dev, prod, maybe someone's name, or even staging. This will give you a unique URL and name your functions as that stage name. And as you can see, stack create progress. Let's go over to CloudFormation. Serverless is going to create a CloudFormation for us. This will handle S3 buckets. It will handle linking API Gateway to the Lambda functions. You should click into it though and check out everything that it's doing. It's pretty impressive. Creating the stack takes a minute or two. To keep the video short, I'm going to go ahead and speed up this portion. When it's done, we'll get our link to click on, and hello! That's pretty cool, huh? I want to go back to the editor and show you guys the event parameter and the context parameter. Lambda will fill these in for us on every function execution. So let's do a JSON dump for this. JSON dumps and return it the event. And I always enjoy wrapping my functions in a try and except. That way, if anything does go wrong at this level, we can return a proper 500. And I do use this in production. So a proper 500 or a response code when necessary, or when anything goes wrong within the execution, is important to have a scalable and stable API, especially if it's going to be customer facing. So let's copy this over, change it to status code 500, and just print make a string of the exception. I'm going to deploy our new code to our develop stage one more time. I want to show you what it means to deploy to different stages. This one is going to be in prod. CD into my documents and my project, which is AWS Overflow. Set up my command, SLS deploy stage prod. Head over to my editor. Let's raise an exception and pass in a string. Oh no, it broke. Let me spell it right. It broke. There we go, and come back here, hit enter, and it looks like our dev environment finished. Let's refresh and see everything we returned. Oh yeah, keep in mind that the information you're seeing here is collected from API Gateway, not Lambda. Lambda is returning it, but the information is a mix actually between Lambda and API Gateway. API Gateway is running Apache in the backend, which is why you get to see a lot of browser information. Another important message you'll see is unauthorized or forbidden and missing authorization token. So keep that in mind. Your URL probably doesn't exist. Let's refresh the page or actually go to our real link and you'll see, oh no, it broke. And that is catching the exception. If we look and inspect the page, look at the console, you'll see it actually returned the status code of 500. So I'm bringing this to a close. Thank you guys for watching, and I'll have more videos about everything to do with AWS.